Hello, welcome to Anima. Today we are going to continue with the part of factorization. In the last class we had done remainder theorem and a few sums on that. Today we are going to continue with factorization, but today we will be doing factor theorem. Factor theorem will, along with some sums, will make it very clear and visible, and I will begin it now. Now, factor theorem states that if a polynomial such as x squared plus ax plus b is divided by a divisor such as x minus c, then fx. Now, polynomial can be written as fx is equal to x squared plus ax plus b. Now here, if it is divided by the divisor x minus c, we first take the divisor as x minus c is equal to 0. Therefore, we take x as c. Now thus, we put the value of c in this equation, which will become fc, which is the remainder of the equation, is equal to c square plus ac plus b. Now in this result which we get, fc, which was the remainder according to remainder theorem, in the factor theorem it becomes 0 because it is the perfect divisor of the polynomial x square plus ax plus b. Therefore x plus x minus c is a factor of x square plus ax plus b. Now we use this theorem for multiple purposes, and fc here becomes 0. We use the theorem in finding variables in a certain expression, like two expressions can be taken having the variables a and b or any other two variables, and we can find both those variables by factor theorem, or it is similar to the remainder theorem, but in this case only the remainder is 0, that is the polynomial is completely divisible by the factor. Now by this statement it states that x minus c is a factor of x squared plus ax plus b. Now there are mainly three types of sums, actually two types, in which one we have to find the factors and the other we have to check whether it is a factor and then factorize it completely, and after that they are basically combined type of sums. Now we will start with a few, like they are x plus 2 and 3x plus 1 is a factor of 6x cubed plus 11x square minus 3x minus 2. Therefore, the factors are x plus 2 and 3x plus 1, and the number polynomial is fx is equal to 6x cubed plus 11x square minus 3x minus 2. Now here they have given us that these two numbers are the factors of this equation, which means that if we take these two as 0 equal to 0, therefore x will be minus 2, where x plus 2 is equal to 0, therefore 2 will be moved to the other side. X plus 2 is equal to 0, which will be x taking to the 0, 2 to taking to the other side, x is equal to minus 2. Now this value of x here will be substituted in this to make sure that it is a factor, and for this number 3x plus 1 we get that 3x plus 1 on taking it equal to 0, 3x is equal to minus 1 taking 1 to the other side, and x is equal to minus 1 by 3 taking 3 to the denominator of 1. Therefore the factors for this equation is minus 2 and minus 1 by 3. Now they are telling to prove this. Now we will apply both these values in this, and if we get the remainder as 0, it is proved that they are both factors of the polynomial. Therefore we will continue. X is equal to minus 2 and minus 1 by 3. Now we will go first with x plus 2 a number. Therefore f minus 2, x will become minus 2 is equal to 6 minus 2 cube from here plus 11 minus 2 square x minus 2 square minus 3 minus 2 minus 2. So this will be the substituted equation, and now we will continue to simplify it further. F minus 2 is equal to 6 minus 2 cube, which will be minus 8, and 6 into minus 8 is minus 48, and 11 minus 2 is equal 11 into minus 2 square, which means minus 2 square is 4, and into 11 means 44, minus 3 into minus 2, minus minus will become positive, therefore 3 into 2 is 6 plus 6 minus 2. Now we will further simplify. Minus 48 and 44 minus 4, minus 4 and 6 minus 1 and 6 will be plus 2 and minus 2, which will be at last 0. Therefore it proves that x plus 2 is the factor of the polynomial. Now we will need to do the same for 3x plus 1. Now it will be, I'm doing it here only. It is minus 1 by 3, putting the value of minus 1 by 3 of this by minus 1 by 3 cube minus 1 by 3 square minus 1 by 3. Now we will simplify it further. Is equal to minus 1 by 3 cube will be minus 1 cube by 3 cube, which means minus 1 by 27. Minus 1 by 27 into 6, 3 and 3 cancels, 2 and 9, which will be minus 2 by 9. Now plus 11 into minus 1 by 3 square, which will be 1 by 9, and minus will become positive. Therefore 11 by 9 plus 11 by 9 minus 3 into minus 1 by 3, which will become 3 and 3 will be cancelled, simply minus 1, and then minus 2 as written. Therefore we will first simplify this. Minus 2, 11. 11 minus 2 is 9. Therefore 9 by 9 by 9. 9 by 9 minus 1. Minus 1 and minus 2 will become 3. Minus 2. 9 and 9 is equal to 1. Minus 3 is equal to minus 2. Therefore, yes, this will be the answer for that. This proves that 3x plus 1 was not the factor of the polynomial 6x cube plus 11x squared minus 3x minus 1. Oh, 1, it will be positive, right? Okay, so it will be minus 1 over here. So 1 and minus 1 is equal to 0. So now both of them are the factor of this equation. I made a mistake over here taking the sign convention. Now x plus 2 by the previous equations stated that f minus 2 is equal to 0. Therefore x plus 2 is a factor of this polynomial, and 3x plus 1, which will give the value of x as minus 1 by 3, stated that f minus 1 by 3 is equal to 0. Thus 3x plus 1 is a factor of 6x cube plus 11x square minus 3x minus 2. Now moving on to the next type of sum, which will be factorizing them. X plus 3 is the factor shown here, and it is the factor of fx, which is 2x squared minus x minus 21. Here we first need to show that x plus 3 is a factor of this polynomial, and then after proving that, by using the by using x plus 3 as the factor, we need to divide this. Now we may use long division method if it is in a simple quadratic equation where x square is written, and that's the for a polynomial of second degree, or if there is a polynomial greater than second degree, which means that has x cube or x to the power 4. Furthermore, we may use long division method. Now for this, we first need to prove it. Taking x plus 3 is equal to 0, 3 will go to the other side, and thus x will become minus 3. Therefore 3 to the other side minus 3. X is equal to minus 3. Taking this, substituting the value of x in this equation, we get f minus 3 is equal to 2 minus 3 square minus 3 minus 21. Now minus 3 square is 9, minus 3 into minus 3 9. Yes, 9 into 2 is 18, which will be 18 minus plus 3 minus 21. 18 plus 3 is itself 21. 21 minus 21, which will be 0. Therefore this is 0. F minus 3 is equal to 0. This proves that minus 3 is a root of this polynomial. Therefore x plus 3 is a factor of this polynomial. Now we can use this for further factorizing the polynomial. It will be 2x square minus x minus 21 x plus 3. We write the divisor here and the dividend to be here. Now x plus 3, we first, if there are two terms over here, we will take only two terms here at one time. Now x need to be turned to 2x square. For that we need to multiply it by 2x. Therefore x into 2x is equal to 2x square. We need not look at 3 and x right now. Only one by one we need to go. Therefore 2x, which will be 2x square plus, it will be plus here, and as a rule of division we will put the opposite sign, and 3 into 2x will be plus 6, which will become minus. Now it will become cancelled. Minus 7x minus 2 will come down. Now we need to make this x as minus 7x. For that, we need to multiply x by minus 7. Therefore minus 7 taken here. X into minus 7 is minus 7x. Rule of division to change the sign, therefore plus. And 3 into minus 7 is minus 21. Rule of division to change the sign, therefore plus. Now plus 7x plus 21 minus 7x minus 21 completely cancelled. Thus this is another factor of 2x minus 7. Now by the statement to show that this polynomial is completely factorized will be 2x cube minus x minus 21 is completely factorized by x plus 3 into 2x minus 7. 2x squared is These are the two factors of this equation. Now the more the number of x square or x cube, x square will have only one factor, I mean two factor, x cube will have three factor, x to the power 4 will have four factors, and carrying on. Therefore, if we have x cube, which we basically have most of the time, then we will get a quadratic equation over here. Therefore, we need to solve that quadratic equation into two normal equations like this. We could have just solved it here only, but if we get a quadratic equation by solving them, we need to solve them into two numbers, like x plus a into x plus b. By that, we will be able to have three numbers, which will be one of the previous one which was already given, and other two new number which will be found out by solving it. Now this was the second type, and the third and the final type would be x plus 1 and x minus 2 are factors of a polynomial, which is f(x) is equal to x cube plus ax square minus bx minus 6, x cube plus ax square minus bx minus 6. By the question, it is very visible that we have to find a and b over here, and we have been given that these two are factors by the question. We need not prove it here. Now these two are factors. Let us take x plus 1 and x minus 2 be 0. Therefore x plus 1 is equal to 0, x will become minus 1, x minus 2 is equal to 0, x will become 2. Now x is equal to minus 1 from this and 2 from this. We will use these values two times in this same equation, and let's go ahead. For f minus 1 is equal to minus 1 cube plus a minus 1 square minus b into minus 1 minus 6. Yes, minus 6. Now we will simplify it further. Minus 1 cube will be minus 1 itself, minus 1 plus 1 minus 1 square is 1 plus a minus b into minus 1, negative negative positive means plus b, minus 6 will be minus 6 itself. Now minus 1 and minus 6 will unite, and it will become a plus b minus 7, and
नाम भी लेना पर्सन का.
is it clear now? I hope it is clear. And a plus b minus 7, and it will become f minus 1 is for factor theorem. If we have been given that this is a factor, since we used to prove it that f minus 1, if we needed to prove it is 0, then f minus 1 over here, by the question it is given that x plus 1 is the factor, therefore f minus 1 is equal to 0 itself. It will be taken because it is a property of factors. Therefore 0 is equal to a plus b minus 7. 7 will be taken to this side, is equal to a plus b is equal to 7. Now a plus b is equal to 7 is one equation which we got. Keep it over here. A plus b is equal to 7. Now we will do the second part of this. Use the same space again. F 2 is equal to 2 cube, x cube 2, yes, 2 cube plus 2 square minus b into 2 minus 6. Simplifying it further, we have taken f2 as 0 because it is a property of factors. 0 is equal to 2 cubed means 8 plus 4 into a, 4a minus 2b, which will be, and then minus 6. Now 8 and minus 6, 2 will be remaining, 2 will be taken to this side. It will give us 4a minus 2b is equal to minus 2. Now dividing 2 on both sides, dividing by 2, we will get 2a minus b is equal to minus 1. Dividing 2. Therefore 2a minus b is equal to minus 1. We will use this equation now. Let's name it as 1 and let's name this as 2. Now 1 plus 2 means a plus b is equal to 7 plus 2ab minus 1. 2a minus b is equal to minus 1 will be added, which will give us minus b and plus b cancelled out. 2a plus a is equal to 3a. 3a is equal to minus 1 plus 7, which will be plus 6. Therefore 1 plus 2 is equal to 3a is equal to 6. 3 will be taken to this side. It will become a is equal to 2. A is equal to 2. So this was all the sums for today, and this would be marking the end of this chapter. These were the main types of the sums which would be coming in the examination. There might be a few more typical sums, but they will be of the same branches. Means there are various types actually, by multiplying the different types together, like factorizing, proving, and then factorizing, taking two polynomials and finding variables. But this was the basics of all those. We use these to find out those variables and etc. So thank you. You may write the queries or any problem in the comments, or you may WhatsApp me at 9874944154. Please like and share. Thank you.